Rationalizing a denominator containing a single term. We do not consider it to be grammatically correct in mathematics to leave a square root in the denominator. This actually stems back from quite a while ago when we had calculators that couldn't handle square roots very well. And so if we had a square root in a denominator, we would have to use a decimal approximation, and dividing by decimals is kind of a pain in the neck. So this is something that still exists today, even though it's not as necessary. But again, the idea is to not leave square roots in the denominator of a fraction. When we have one of these, what we do is multiply by that square root. I'm going to multiply both the numerator and the denominator by the square root of 2. The reason for this is that now in the denominator, when I multiply these two items together, the square root is going to end up going away. So in the numerator, I'll have 12 times. I'll combine the two square roots together and have 3 times 2 underneath the radical sign. And then in the denominator, we'll have 2 times 2, which is 4. So I'll have 12 times the square root of 6 over the square root of 4, or 12 square root 6 over 2. And now for my final step, I'll divide that 12 by 2 and get a final answer of 6 times the square root of 6. Looking at example B, we'll follow that same idea. Let's multiply both the numerator and the denominator by the square root of 162. In the numerator, I'll have 18 times the square root of 162. And in the denominator, we have the square root of 162 times 162, which is just 162. Let's see if we can break that down further. Does 18 divide evenly into 162? Let me grab my calculator and check this. Yeah, it goes in 9 times. So it looks like I can simplify these to be 1 over 9. So first thing I can do. But then 162, we just found out, is 9 times 18, or 9 times 9 times 2. I can simplify that to be, I'm going to ignore that 1 that's sitting in the front there. Looks like this is the square root of 81 times 2. Or the square root of 81 times the square root of 2. Looks like we've got 9 root 2 over 9, which is just the square root of 2. Sometimes we have square roots in a denominator, but there's something else that's sitting there. Looking at example A, I've got 2 plus the square root of 3. If I follow the same strategy that I had used in the last problem, and I multiply by square root of 3, what'll end up happening is I'll have 2 times the square root of 3, and then square root of 3 times square root of 3 will just be 3. One of the square roots goes away, but I still have another square root there. So that strategy we used a minute ago isn't going to work. Instead, what we do is we multiply by what's called the conjugate. The conjugate looks identical to the square root, but to the terms that we have. Oops. But I change the sign that's in between the two terms. So the conjugate would be 2 minus the square root of 3. The reason for that is we're going to use the difference of squares to our advantage. When I multiply these two items together, I'll multiply the first terms together. 2 times 2 is 4. I'll multiply the outer terms. That'll be minus 2 square root 3. The inner terms will give me plus 2 square root 3. And then the last terms will be minus the square root of 9. Notice that the middle terms here are going to cancel each other out, and I end up with 4 minus 3, or just 1. That is the way that we can get rid of the square root, is to multiply by its conjugate, because the two terms that are left with a square root in the middle cancel, and the one that we have from the end that came from these two multiplied together, because there's the same exact number, the square root symbol ends up going away. So over here, we're going to multiply. We have to multiply the top and the bottom by the exact same thing, right? Because it's a form of 1. So 2 minus the square root of 3 over 2 minus the square root of 3. We just did the math over there on the side, and we saw that our denominator, our denominator is going to end up being 1. We did that work over there already. And then in the numerator, we're going to distribute that 7 to both of these items. So we'll have 7 times 2 is 14 minus 7 times the square root of 3. And so it looks like our final answer here is 14 minus 7 times the square root of 3. Going on to example B, let's do some side work. We know that we're going to want to multiply by the conjugate 1 plus the square root of 17. 1 plus the square root of 17. Let's do a little work over here on the side to see what we get when that happens. I've got 1 minus root 17 times 1 plus root 17. When I multiply the first terms together, I get 1. I know from what I did before that when I multiply the inner and the outer, those are going to cancel. So I really only need to think about multiplying the first terms together and then multiplying the last terms together. Those last terms are always the same. So what I'm ending up with is, in this case, minus 17, or a negative 16 overall. So in the numerator, I'll distribute that 8. So I'm going to get 8 plus 8 times the square root of 17. And in the denominator there, we have a negative 16 from that side work that we did. I have 3 terms, 2 in the numerator and 1 in the denominator, and they're all divisible by 2. This, and this are all divisible by 2. So I can rewrite this to be, let's see, they're all divisible by 8. That would be even better. 1 plus square root 17 over negative 2. And if you don't like that negative in the bottom, you can move it up to the top. Negative 1 minus the square root of 17 over 2.